Good morning. Can you hear me? Okay. Okay. This is our first chemistry lesson. Now we discussed, I think, 10 lessons. This is our 10th lesson, thermochemistry, our first chemistry lesson. Right? This lesson you have tuned. I will send it. I'll post this today because yesterday I received the printed one. Okay, I will send it today. Today I will explain the basic of thermochemistry. And this thermochemistry, we have calculation part as well. We have calculation part as well as theory part. So the basic of chemistry actually. The basic of chemistry. Very simple things we discussing. The actually we in thermochemistry in heat lesson, our last lesson we discussed how this heat energy, thermal energy involved for physical changes. Physical changes mean like physical state change, expansion, like physical changes. But in this lesson, we discussing how thermal energy, heat energy involving for uh, chemical reactions. How thermal energy involving for chemical reactions. Chemical reactions. You know some reactions. As example, think acid-base reaction. Think it is HCl acid, hydrochloric acid react with sodium hydroxide. It's a powerful base in AOH. In AOH, sodium hydroxide, it's a powerful base, caused soda, and react with HCl, it's a acid base. This type reactions we called as neutralizing reactions. Neutralizing because acid and base, it's make a mineral. Sodium chloride tama hada. Sodium and chloride and water. Right? These type reactions, HCl plus sodium hydroxide, it's producing sodium chloride, NaCl and water, H2O. Yeah, this type reactions we called. Okay, what happened to the surface of this beaker while take place acid-base reaction? Heating, right? Then it has some relationship within heat energy, right? This thermal chemical reaction has some relationship. Okay, this type relationships we discussing in thermochemistry, how heat energy involving for chemical reactions. Chemical reactions. Okay, I'll give you a soft copy of this tube. The printed one I'll send before next week. Okay, now you can download soft copy in the group. Okay. Okay, let's start. It is lesson number 11. Lesson number 11, thermochemistry. This is our first chemistry lesson. Okay. Okay, as I explained in the introduction part, in previous lesson, in heat energy lesson, we discussed how heat energy involving for physical changes like thermal expansion. Expansion is a physical change. What else? The physical state change, how to involve heat, and sometimes heat releasing, sometimes heat absorbing. I told melting, what else? Endothermic physical state changes. I explained in the last lesson. Endothermic physical state changes, that mean heat absorbing. What are the examples? Melting, vaporization, sublimation. They are endothermic. Endothermic means heat absorbing to change the physical state. They are physical changes. They are physical thing. Physical changes. They are physical changes. Now, any chemical changes in, as example, uh, ice cube, it's a solid state. If it is converted to liquid state, it is water. Water in solid state and convert into liquid state. H2O, solid state to convert into water in liquid state. H2O, liquid state. No any chemical change, only physically change the physical state. That's called as melting. Not only that, vaporization, sublimation, They are endothermic process. What are the exothermic process we discussed in the last lesson? Exothermic physical state changes. Yeah, opposite side. Freezing, condensation, deposition. They are the exothermic physical state changes. They also physical state changes. If you got the opposite side, water convert into, this is freezing, right? Water convert into ice. Water convert into solid water. That's mean freezing, right? The freezing is a exothermic process, but there is no any chemical change. Only change the physical state of matter. But in this lesson, we discussing how heat energy, thermal energy involving for chemical reactions, chemical changes. Understood? That's the base of this lesson. That's the basic of this lesson. Okay. Right. Energy, yeah, energy in work energy lesson, I told what's the meaning of energy. Do you remember? We discussed the energy mean. What's the meaning of work? What's the meaning of work? I'm asking in physics. Work energy power lesson. The work mean. අපි කොහොමද work explain කරේ Humeth? How we can define the work in work energy power lesson? අපි work එකක් කියන්නේ කාර්යයක් කියන්නේ met me. What's the meaning of work? Work. Yeah, very good. A work is a measure of energy to transfer. Sorry, a measure of energy transfer when a force displays an object. Very good. When we apply an external force, by an external force applied, by this external force to displace this object, to displace the energy transformation. A measure of energy transformation is a work, right? Then that means it's a measure of energy. That's why the work unit is joules, right? The work unit is not Newton meter. The work standard unit is joule. See, what's the meaning of energy? Energy means the capacity of, yeah, very good, mate. The energy transferred to an object by applied force which cause the object to move for displacement, right? For displacement. All right. Okay. Then what's the meaning of energy? The energy is the capacity of doing work. Capacity of doing work. The energy also I explained in the work energy power lesson, right? The energy means the capacity of doing work. Capacity of doing work, or capacity of do work or produce heat. Now it has a specific word, new word. The energy is capacity to do work or produce heat. Produce heat. This produce heat part I will explain in the middle of this lesson. Okay, thermochemistry. This is a basic introduction of thermochemistry. Thermochemistry is a branch of chemistry that deals with energy change, particularly heat change that occur during a chemical reactions. Chemical reactions in, yeah, energy cannot be created or destroyed. That's we called as maybe energy conservation law. Energy conservation law. Yeah, energy is a conservation. Conservation means we can't be created or destroyed. In work energy power lesson, we discussed another law, mechanical energy conservation law as well. අපි ගොඩක් ගණන් හදලා තියෙන mechanical energy conservation law වලින් එකත් බලන්න. හරි. Okay, thermochemistry mean you want to understand the thermochemistry mean we discussing thermal energy, heat energy involving for including chemical reactions. Physical changes also possible, physical transformation also okay. But last lesson we only discussed about physical changes. But in this lesson we discussing physical changes plus chemical changes. Chemical changes. Okay, that's the difference. That's a difference. Okay, do you know what is the main energy source of the earth? The main energy type of the earth? Yeah, the sun is the main energy type. Yeah, the sunlight is the main energy source of earth. You know, this may the energy amount, the amount of energy in our earth or universe, that we consider as a constant value. The energy quantity is a constant value. Why we call it is a constant value? See, energy is constant. Energy is a constant amount. See, this is the thing. This is the sun, right? The sun is the main energy source of the earth. It releases heat and light energy. This heat and light energy, think this earth. This heat and light energy absorbed by plants, and this energy absorbed by plants, and they doing photosynthesis process, right? Photosynthesis process. In the photosynthesis process, this heat energy, heat and the solar energy convert into which energy? In the photosynthesis process, this heat energy, what happened to this heat energy? Yeah, it is converted to chemical energy. In the photosynthesis process, this heat energy convert into chemical energy. Heat energy convert into chemical energy, right? Heat energy convert into chemical energy. Now animals, what happened? They depend on the plant material. Animals depend on the plant material. Then this chemical energy transferred to animals as well. Animals as well, right? Animals. Heat energy absorbed by plants and doing photosynthesis process. In the photosynthesis process, heat energy convert into chemical energy. In chemical energy transfer to animals, due to animals depend on plant material, right? Okay, now at the end of animals and plant lifetime, dead plant and animal material deposit into ground, right? Deposit in ground. Then what happened? They digest millions of years, in lithosphere. Lithosphere mean our land. Inside of the land, it is converted into fossil fuels. Fossil fuels. This energy convert into fossil fuels. Fossil fuels. Then industries and vehicles, after purification, we again use this, again using this fossil fuels and again burning. In the burning process, burning, again heat energy released to the atmosphere. It's a cyclic process, right? It's a cyclic process. Always the amount of heat energy, it is a constant amount. Always what happened? The amount of energy is a constant amount. This energy transfer from one energy to another energy type. There are different types of energy types I explained in the work energy power lesson, right? Heat energy, light energy, chemical energy, mechanical energy, what else? Sound energy, electric energy, magnetic energy, nucleic energy, right? Different types of energy. However, the amount of energy is same amount, constant. What happened? One energy type to it is convert from one energy to another form, right? One to another, converting and available everywhere, right? The amount of energy, the amount is constant amount in our universe. Okay. Now, this is a මෙතන ඒක තමයි මේ දීලා තියෙන්නේ. Right. Okay. That's the basic of lesson. Okay. From here, it is very important. Okay. Write down in your book the topic thermochemistry, and I will give you short note, and I will give you this full note. මේ tute එකත් මම දාන්නම් ඔයාලට thermochemistry and kinetic chemistry both tute I will post. I have already printed them. I'll post it today, Sunday. Tomorrow I'll post both tutes. Then you can collect before next class. Okay, write down thermochemistry. Topic thermochemistry. Thermochemistry. And write down basic concept of thermochemistry. Basic concept of thermochemistry. Basic concepts of thermochemistry. Basic concepts of thermochemistry. Basic concepts of thermochemistry. Basic concepts of thermochemistry. Okay, our first basic concept, heat. Heat is energy, you already know. Heat is energy, it is formed due to temperature difference, that you already know. Write down the first basic concept, heat. First basic concept, heat. First basic concept, heat. Write down, heat is an energy type. Heat is an energy type which is formed due to temperature difference. Heat is an energy type which is formed due to temperature difference. It's energy, therefore the unit is joule, that you already know. Or we can get kilojoules or calories. Calories I will explain later. Right. Okay. That is the first basic concept. The first one is heat. Heat is a type of energy. Right? අපි මේක ඉගෙන ගන්න මේ basic words to understand this lesson. Right? It is not the lesson. They are the basic words to understand this lesson. The first basic concept is heat. What's the meaning of heat? It's a type of energy which is formed due to temperature difference. You know, heat energy always transfer from high temperature to low temperature. Right? High temperature to low temperature. If you got I think it is ice cube. Ice cube, it is minus 10 Celsius. If it is having normal environment, what happened? Normal temperature 30 Celsius. What happened? Ice cube, heat absorbing. Heat always transfer from high temperature to low temperature. High temperature to low temperature. There are different heat transformation methods also we discussed last day, right? 3 thermal transformation methods. What are they? What are the 3 thermal transformation methods? Conduction, convection, and radiation. I think you can remember their differences. Conduction means two solid objects without net molecule movements. Without net molecule movement, molecule to molecule heat transformation, it is conduction. Convection means due to density difference, the heat transfer as it is molecule. Molecule එකත් එක්කම heat එක අරගෙන යන එක තමයි convection. Radiation means you should have this type short idea, right? You should have able to explain this concept in a short way, right? Radiation means idea එක මොකක්ද? Radiation means heat energy transfer without using any medium. Without using any medium. Not only vacuum, it is possible to transfer heat through atmosphere as well. Normal gas air available medium as well, but the thing is it's not using air molecules, not using air molecules. Heat transfer as electromagnetic waves, electromagnetic waves, right? Right. The first thing, okay, right? Heat energy. Heat is a type of energy which is formed due to temperature difference, and heat energy always transforms from high temperature to low temperature, and its unit is joules or kilojoule. The standard unit is joule. The standard unit is joule. Okay, write down the second basic concept, work. The second basic concept, work. Okay, the work also you already know. What's the meaning of work? The work is a measure of energy transformation to displace an object by an external force. Okay, write down. A measure of energy transformation. A measure of energy transformation to displace an object. To displace an object by an external force. By an external force. Is called as work. Is called as work. Okay, this may expansion and compression process I will explain later. Still you don't know what's the meaning of system and surrounding. Without this knowledge you can't understand this. I'll explain that later. May first let's try to understand this basic concept, right? Basic concept. Okay, the third concept, energy. Energy. Energy you already know. දැන් මේ චර වෙලා කරපු ඔක්කොම ඔයාලා දන්නවා. කලින් අපි කරලා තියෙන්නේ. I gave you because these words compulsory to understand the lessons after this basic concept. When you're discussing chemical changes, these words very important. They are the key words to understand this lesson. Right. The third one, energy. What's the meaning of energy? What's the meaning of energy? The energy is the capacity of doing work. Write down, the energy is the capacity to doing work. The capacity to doing work. Capacity to doing work. Yeah, it is given according to the law of conservation energy. The energy of universe is a constant amount. The amount of energy in universe, it's a constant amount. It's a constant amount. It's a constant amount. Right. Okay, write down the flow. Yeah, that's the main keywords. Okay, write down the fourth keyword, system. මෙතන තමයි වැදගත්ම. හරි. System. System. Okay, what's the meaning of system? The system mean the system එකක් කියන්නේ මොකක්ද? System mean පද්ධතියක්. Right? System. What's the meaning of system? Remember, in chemistry, a system is a selected area like this. Think example, I'm going to doing an experiment in a laboratory, right? In laboratory. Think you doing whatever chemical reaction inside the test tube. Inside test tube. Doing chemical reaction inside the test tube. Then this test tube is a system. It's considering area of the universe for any study. Take another example. You're doing experiment in a pond. Pond එකක fish ලාගෙන මොනවා හරි water quality or whatever you're doing experiment. Then the pond is a system. The pond is a system. I got the selected area is in the universe for whatever study. හරි study එකකට අපි select කරගන්නපු area එකක් තමයි. Selected area for whatever experiment or study that we call as the system in the chemistry. Understood? What's the meaning of system? It's a selected area for particular study. Right? It's a selected area from the universe for a particular study. Right? Take another example. So you doing experiment about plants. Plant එකක් ගමු එහෙම. Plant. Local plant එකක්, right? You're doing a nutrition requirement and whatever disease, or you're doing some experiment. Then the plant is the system. The plant is a system, right? If not, if you're doing experiment for whatever part of this plant, අපි හිතමු මේ plant එකේ part එකකට එක branch එකකට විතරක් ඔයාලා experiment එක කරනවා. Then this branch is a system. I got with me? You and me? The selected area from the universe for a particular study or experiment. Right? That's the meaning of system. The selected area for a particular study or experiment from the universe. What's the meaning of universe? Okay, I'll explain later what's the meaning of universe. Hi. Okay, then up to now you want to understand what's the meaning of systems. අපි මොනවද කරන්න කියලා ඔයාලට තව ටිකක් යද්දි තේරෙයි. We discussing basic terms to understand this lesson. Right? They are basic terms to understand these lessons. Hi. System. What's the meaning of system? It's a particular selected area. Selected area from the universe. It is not limitation. Sometimes it is very small test tube. System is very small test tube. Sometimes it is an egg. Sometimes it is a cell. If you're doing experiment about our cell, about our body, whatever body investigation, then the cell is a system. Cell is the system. Right? If you're doing experiment in sea, we can select whatever think 10 square meter or 20, 100 square meter area for our study, right? It is our system. Selected area is a system. Selected area, right? That's a simple meaning of system. Okay, write down the definition. Write down system. Fourth subtopic system. A selected area, a selected area, a selected area for a particular study or experiment. A selected area for a particular study or experiment from the universe. From the universe. Is called as a system. 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 Okay, write down example. Example. Selected plant. Selected plant. Selected test tube. Selected plant. Selected test tube. Selected pond area. Selected pond area. Selected pond area. Selected cell. Cell එකක් අපි select කරගත්තොත් එයා තමයි system එක. Right? Actually it is a assuming thing. අපි හදාගන්න එකක්. ඒක කොහෙවත් තියෙන එකක් නෙමෙයි. හරිද? System is not available spatially everywhere. It's a assuming, right? It's an assumption. අපි තමයි ඒක හදාගන්න, right? Okay, that's the meaning of system. Okay, write down the next one. Write down the next subtopic. Fifth one, surrounding. Fifth one, surrounding. 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 Okay, what's the meaning of the surrounding? Surrounding mean it's a very simple thing. You can understand everything by this diagram. Think this is a universe, completely universe, right? This is our universe. Make හිතමුකෝ අපි universe එක කියලා, right? අපි විශ්වය කියන්නේ universe. If I select particular area for study from this universe, that we call as system. That's the meaning of system. That can be plant, cell, or test tube, or pond, selected sea area, anywhere. Selected area for a particular study that we call as system, right? This is the meaning of this is a selected area, that's a system. Except system, other all areas in the universe we called as surrounding. Surrounding. Surrounding mean except system. System එක නැතුව, without system, other all areas in the universe. This full one is universe. Universe. Understood? Universe. The selected area from the universe is the system. Except system, other all areas in the universe we called as surrounding. Clear? They are very simple things, but you should have full idea what's the meaning of system, surrounding, and now we are going to discuss in relationship between them, right? Therefore, මේවා හරියටම දැනගන්න ඕන with perfect definitions, right? Okay. Write down fifth topic, surrounding. surrounding. Surrounding, write down, except system, other all area in the universe. Except system, other all area in the universe consider as surrounding. Consider as surrounding. Other all area in the universe except system, other all area in the universe consider as surrounding. 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 Okay, write down the, before drawing this, write down the final key point. Final key point. System boundary. Final sixth key point. System boundary. System boundary. Sixth one, system boundary. Hari. Mokadda me, what's the meaning of system boundary? System boundary. Remember this system and surrounding separating layer, separating limit is the system boundary. This is the system boundary. This green color line is the system boundary. System boundary. System boundary. Understood? This system and surrounding separating layer is the system boundary. Right? This system boundary very important to discussing while we discussing relationships between system and surrounding. The system boundary very important. Right? The system boundary is the separating layer. System and surrounding. System and surrounding separating layer we called as a system boundary. Hari. Memory under. The system and surrounding. The system and surrounding separate surface. Separating surface. The system and surrounding separating surface. Separating surface is called as the system boundary. Separating surface is called as the system boundary. It is a system boundary. Separating surface is called as system boundary. And write down it stomach. That was exam question, right? Make MCQ එකකට අහලා තිබ්බා මේ point එක. There was MCQ question in 2018 as I remember. There was MCQ question about this system. System ගැන තමයි අහලා තිබ්බේ. මේ term එක point එකකට දීලා තිබ්බා. System boundary. System boundary always should be a physical. Should be physical. Is it correct? Is it physical barrier? Physical boundary? Always? No. It sometimes it is physical. As example, if you got test tube, අපි test tube එකක් ගත්තොත්, if you got test tube, think it is test tube. Test tube, this is the system. The internal test tube area is the system, the selected area for particular study. Except system, other all area in the universe, that's we called as surrounding. This is surrounding, right? This is surrounding. The glass layer, this glass surface is a system boundary. It has a physical boundary, right? It has a physical boundary. No problem. It has a physical boundary. But if we think it has a physical boundary, this glass layer is a boundary. Take another example. Apigamu. We select some area, some volume of atmosphere to investigate the air composition and the air purity, right? To investigate the air purification and air pollution, right? Is there any physical barrier? No, we have to get a virtual. Imagine the boundary we have to imagine, right? No specific physical boundary. Physical boundary එකක් නැහැ. එතකොට අපිට imagine කරලා virtual boundary එකක් තමයි හදා ගන්න වෙන්නේ, right? Using satellites or using maps, we can think we select whatever area for investigate the sea water quality. අපි මේ වගේ area එකක් select කරගන්න in the deep sea. Is there any physical boundary? No. Using satellites or whatever technology, we can have a virtual boundary, right? No physical boundary always. No physical boundary always, right? Okay. Remember, this boundary can be real, that means physical one, or imaginary virtual boundary. Understood? Sometimes it is physical. Okay, sometimes it is imaginary boundary. Understood? Dirun? Hi. Okay, write down star mark, the final point. The system boundary can be a physical one or imaginary one, right? Imaginary, no physical boundary, but we imagine the boundary. Okay, now you can draw clearly what's the meaning of system, surrounding, and boundary. Hari. මෙන්න මෙයා තමා, this is a selected area. Think this is a selected area. It's a system. This is a system. What's the meaning of system? What's the meaning of system? It is a selected area for particular study or experiment, right? For chemical or physical, whatever experiment, selected area, that's the meaning of system. That's the meaning of system, right? The second thing, without system, the other all area, think this is a universe. This is a universe. Right. This is a universe. Except system, other all area in the universe all area in the universe that we call as surrounding. This is a surrounding, right? The system and surrounding separate surface, we call it is physical or imaginary one. It is a system boundary. Understood? Okay, that's a summary of the key words we discussed up to now. Understood? Okay, draw this and label clearly. Right? Complete. Madhyam. System. Okay, what are the key points we discussed up now? We discussed about heat. Heat is a it's a type of energy due to temperature difference. Second, the work, you already know, it's a measure of energy transformation to displace an object. Work. And then we discussed about energy. What's the meaning of energy? That's work doing capacity, the capacity of doing work. Then we discussed about system. System means selected area from the universe for study. Surrounding, without system are the whole area in the universe, that's a surrounding. Then what's the meaning of system boundary? Final one. System boundary is the this surface separate the system and boundary. So system and surrounding separating surface we called as a system boundary. Sometimes it is a physical boundary and sometimes it is virtual imaginary boundary. Right? That's a summary we discussed up to now. Understood? Tulen? PNL? Right. Now, do you know me? You know, you already know what's the meaning of energy, right? Energy means the work doing capacity, the work doing ability. What's the meaning of matter? Matters mean how many types of matters? In last lesson we discussed. How many types of matters? 3 types of matters. What are they? Solids, liquids and gases. Yeah. Matters mean solids, liquids and gases. Solid, liquids and gases. Actually, what's the definition of matters? How we can define matters? You mean how we can define matters? Matters. You any? Matters. Padartha කියලා කියන. Matters. What's the meaning of matters? The definition I need. Last lesson we discussed about every type of matters and physical matters changes their physical state. Yeah. What's the meaning of matters? Yeah, very good. Very good. Matters we discussed last lesson. Yeah, which occupies space and mass. Yeah. Very good. Anything, any substance with mass and taking some space in the surrounding with some volume, right? Okay, good. Okay, solid, liquid and gases are the matters. Solid, liquid and gases are the matters. එක මං හිතනවා ඒකත් ඕන දාගන්න. Matters are in substance with mass and some occupied some space in the surrounding. Right. Solids, liquids and gases are the main matter types. Now, we discuss system, surrounding, universe, system boundary. I told according to energy conservation law, the total energy amount in the universe is, it's a constant value, right? Constant energy amount in one universe. In one universe, the amount of energy is a constant. That's why it is no energy cannot be created or destroyed. It is the possibility is only convert one energy type to another type, right? It can only convert, cannot create or destroy it according to law of energy conservation, right? Okay, write down the next topic. Write down the next topic. Write down the next topic. Types of systems. Types of systems. Types of systems. Types of systems. Now you already know what is the meaning of system. It's a particular selected area for a study, right? The systems mainly 3 types. Systems mainly 3 types. Systems mainly 3 types. Bala. The systems mainly 3 types. Systems, that means selected area or from the universe. The systems we can classify it into 3 main types. Divide into 3 main types. The first one is open system. Open system. Open system. The second one is closed system. Closed system. The final one is isolated system. Isolated system. Open system, closed system and isolated system. Okay, they are the main types of systems in our future lessons, right? We're discussing in future lessons. In chemistry lessons, open system closed system and isolated system. Okay, what's the meaning of open system now? Open, think it is a system. Think it is a system. Open system. Open system make classification. This system classification based on, remember, based on energy and matter exchanging through the boundary. Make a based in energy and matter. Energy and matter. Energy and matter exchange through the boundary. මේව නම් හැමදාම වගේ විභාගේ කොහේ හරි අහනවා. හරිද? Structured SAO, MCQ, anywhere these points asking. They are key points. Hari. Open system. Open system mean, think this is a system. This is a system. This is a system. Energy and matter both exchanging. ඒ කියන්නේ එළියට යන්නත් පුළුවන්. ඇතුළට insert වෙන්නත් පුළුවන්. Energy and matter both exchange through the system boundary. Energy and matter. Energy mean heat energy, light energy, everything. Energy and matters. Matters mean solid, liquid and gases. Both possible to transfer through the system boundary. Not transfer, exchange. දෙපැත්තටම වෙන්න පුළුවන් exchange. Energy and matter. Energy okay and matter okay. Right? Energy and matter both exchanging through the boundary between system and surrounding. Energy and both exchange through the boundary between system and surrounding. Right? What are the examples for open system? What are the examples for open system? If I got open test tube, get open test tube. Think it is whatever reactant and see any possible to release some gases. Think මෙතන hydrogen gas එක හැදෙනවා නම් hydrogen gas is released, right? If the heat and light energy enter to the system, right? If I got open test tube, it's a open system. Open system. What are the examples? What else are the examples for open system? Mario, what are the other examples for open system? If I got our cell, is it open or closed? Open system or not? Yeah, human body. Yeah, very good. Human body is an open system. Very good. Our cell also open system. Open system. It's respirate, cellular respiration, absorb oxygen for respirate and releasing metabolic waste. Right. What else examples? Yeah, the boiling pot. Very good. අපි ගත්තොත් glass of tea, cup of tea. Yeah, swimming pool. Very good. What else? Yeah, everywhere a lot of systems are open system, right? Natural things. අපි pond එකක් ගත්තාම it's open system. Plant open system because it's may exchange matters. For photosynthesis, carbon dioxide and oxygen exchange, and nutrition's water absorbing, right? It's a open system. Open system. What else? Tawa. Open systems. Yeah, vehicle engine. Yeah. Vehicle engines. Very good. What else? You met examples? Yeah, plants. Yes, good. Plants, because use sunlight for photosynthesis and water absorbing, respiration, oxygen releasing in the photosynthesis, everything. Energy and matter both exchanging. Yeah, I think now you have idea. Open system means system. Yeah, ocean. Yes, ocean. Open system is a system. It is possible to exchange both energy and matter. Both energy and matter. Through the, it is exchange energy and matter both through the boundary between system and surrounding. It is exchanging, right? It's exchange. Okay, let's move into closed system. Closed system. What's the meaning of closed systems? What's the meaning of this closed system? Closed system is system. Closed system is a system. Its only release system. It's only exchange energy through the boundary. No matter exchange. No matter exchange. It's only exchange energy through the boundary. It's only exchange energy. Energy exchange, no matter exchange. No matter exchange. What are the example? If I got a sealed cup of tea, sealed cup of tea, is it open or closed system? It's a closed system. If you got sealed test tube, sealed test tube, it is only energy exchange, no matter exchange, right? Then මෙහෙම අපි මේක seal කරොත්, think it is a test tube. It's a test tube. Now it is sealed. Seal, right? Only energy is flowing through this glass layer, but no matter exchange. The producing gas is not releasing, right? It is a closed system. What are the other examples? What else? Other examples? Very good. Lot of electric items. Bulbs. Bulb එකක් ගත්තම මොකද වෙන්නේ? It's supply electric energy convert into light and heat energy, right? Light and heat energy, no matter exchange. Yeah, very good. Sealed flask, very good. Okay, they are the closed systems. I think you have idea. Okay, now I think you can understand what's the meaning of isolated system. Then what's the meaning of isolated system? Can you imagine? Yeah, systems without exchange anything. Isolated, separated one. Isolated system mean system, there is a system. It's not exchanging energy or matter anything. No exchanging energy or matter. Energy not exchanging, matter not exchanging. Right. What are the examples? The isolated system is a system. It is not exchanging anything, energy or matter, anything. Fully isolated. What are the examples? Yeah, thermoplast, very good. Thermoplast, it is, we can, in our lesson, we consider as isolated system, but it is not full isolated, right? Because it slowly heat transform. It's slowly heat exchanging, right? ඒක නිසානේ වතුර මේ පැයහක් වගේ තියෙද්දි නෙමෙයි, right? It's transfer heat, but it is very slow. Yeah, we can consider as isolated system. What else? Other examples? Other examples? Other examples? Okay, what about universe? Because there is no other things outside. Yeah, yeah. Universe. Yeah, universe is a isolated system. Yeah, it is actually then universe එකම system එකක් විදිහට ගත්තොත් yeah, yeah, that one also isolated, but we discuss in universe එක normally අපි system එකක් විදිහට ගන්නෑ, right? Universe, the selected area from the universe is the system. A well closed glass gas cylinder. No, gas cylinder mean home used one. No, it is not an isolated one. It is not isolated because it's heating or cooling, right? Heat made energy transformation. It's a closed system. It's a closed one. Isolated, another isolated system. If you got vacuum, vacuum is not an isolated thing. Vacuum, the heat energy flowing, you meant heat energy flowing to radiation. You meant heat energy. It is possible to transfer heat energy by radiation. Yeah, it is not a closed system. Isolated. So if I got a rigiform box, styrofoam box, normally ice transportation and fish transportation in a rigiform box. Why? If you got sealed rigiform box, it is isolated one. It's isolated one. Sealed rigiform box, isolated one. And the thermoplast we consider as isolated. And yeah, they are the example. Okay. Please draw this chart and write down with 3 examples. Method examples. Example for open system, example for closed system, and example for isolated system. India. Right. Please complete this chart. Calorimeter, can we take calorimeter? If it is closed calorimeter, it's correct. Complete the sealed calorimeter, it's correct. If it is open calorimeter, it is open system, right? Okay. Complete, Yoni? Okay. Okay, I will summarize what we discussed. Very simple things, very basic things we discussed up to now. We discussed basic terms and only types of systems. Types of systems, we have 3 types: open system, closed systems, and isolated system. Open system mean energy and matter both exchanging through the boundary, system boundary. Closed system mean only energy exchange through the system boundary. Isolated system mean no energy or matter doesn't exchanging through the boundary. Right? They are the 3 types of systems. 3 types of systems. Hi. Now let's move into start calculation part. Okay, the basic part is completed. The basic is complete. Hi. Okay, let's do one calculation. Okay, write down. An air balloon was expanded by absorbing 600 joules of heat energy. Heat energy, right? The work done by the work done by the work done by the balloon is 150 joules. 150 joules. 150 joules. Right? 150 joules. Calculate the internal energy change of this balloon, of this system. Okay. මේ වගේ exam MCQ හැම සැරේම වගේ ඇවිත් තියෙනවා. Right? This is from basic part. අපි දැන් දැනට discuss කරපු ටික තමයි මේ ඇවිත් තියෙන්නේ. Right. I told in the tute in energy part I told this මම part එකක් මේ skip කරා මතකයි. I skip one part. Yeah, this point. Yeah, expand and compression. Okay. Now this question given, an air balloon was expanded by absorbing 600 joules of heat. You know, for expansion need to be absorb heat, that you already know, right? Increase molecule spaces, increase molecule vibration and expanding, right? Heat energy, and the work done by the balloon is 150 joules. Work done by the balloon. Work done by the balloon. That's the important thing. Work done by the balloon. By mean the balloon doing some work, right? Then heat energy increasing or decreasing. ඒ කියන්නේ අපි මොනවා හරි work එකක් කරනවා. Then our energy level increasing or decreasing. The balloon doing some work. It is decreasing, yes. Then 150 is decreasing. Okay, think. මේක ලියන්න. හරි. මම exam questions වලට යන් මේක අපි කරලා. Right. Now think this is a balloon. This is a balloon. Think this is a balloon. It is a system now, right? It's a system. It's a system, right? The selected area is balloon now. Expanded by absorbing 600 joules of. Now think this type calculation, the very easy method is this. හරිද? අපි හිතමු මෙයාගේ initially the energy level is 100. ඕනේ ඇලුව එකක් දාගන්න, right? Initial energy level is 100. Right? Initial energy level 100. If it is absorbed for expansion, if it is absorbed 600 joule, now what is the internal energy level? What's the internal energy level? Dule, what's the internal energy? It's absorbing 600. Initially it is 100. තව 600 absorb වෙනවා. Then what is the energy level? With me. Now 700. Now 700. 700. And the balloon doing the work done by the balloon. ඒ කියන්නේ balloon එක work එකක් කරලා තියෙනවා කොච්චරද? The work mean the energy transformation. It's measure of energy transformation. Then it's doing some work. It's doing some work mean දැන් මෙයාගේ 700 තියෙන එකකින් මෙයා ටිකක් අයින් කරනවා. කීයද? 150 joules. Then what is the internal energy remaining? Given 550. 550. Now the question asks, what is the internal energy change? Internal energy change mean, remember, internal energy change mean delta E. Delta E mean final energy minus initial energy, right? Now final energy level 550 minus initial කීයද අපි ගත්තේ 100. Then answer plus 450 joule is the internal energy change. Understood? Internal energy change plus 450. Understood? මෙයාට ඕන එකක් ගන්න පුළුවන්. මෙයා 0 කියලා ගත්තත් the answer correct. Right? 0 කියලා ගන්නකො මෙයා. 0, then absorb 600, it is 600 work done by the balloon is 150, then it is 600 minus 150 mean 450, right? Answer 450. Okay, draw this and write down the answer. 450 joules. 450 joule is the internal energy difference. Internal energy difference. Okay, sorry. Complete? Document? Complete? All right. Okay, let's do question number 2. Question number 2. An open system with 300 joules internal energy An open system with 300 joule internal energy is doing 200 joule work on the surrounding. Right? On the surrounding. Calculate the internal energy change. Energy change of the system. Calculate the internal energy change of the system. Calculate the internal energy change of the system. Okay. Can you get this value? Same type, same method. An open system with 300 joule internal energy is doing 200 joule work on the surrounding. It's doing work on the surrounding, right? That means system doing some work. System doing some work. What's the answer? The question asks what is the internal energy change? Internal energy change. Internal energy change. Mariam, what's the answer? Always follow previous method. Done? With me? What's the answer? Yoni? Dolen? Senura? Sanura? Very good. No, no, Dino. No, Dolen. Mehima Hadan. Follow this method. This is a system, right? It's an open system. Initially, it's contained 300 joule internal energy. And the system doing work on the surrounding. Work on the surrounding means system doing some work, right? System doing some work. Then heat release 200 joule. Then the remain is 100 joule, right? Itaru 100. Then what is the meaning of delta E? Final energy minus initial energy. 100 minus 300 equal 200 joule, but it is minus 200 joule. Minus 200 joule. Understood with me? Follow this method. Follow this method. It is not asking final energy level. The energy difference, energy change is asking, right? Energy change is asking. If it is final energy level, it is 100. That's correct. Mariam, I got? Tanure? Okay, let's do one more question. හරි තව එකක් හදමු third one. An open system හරි ඉක්මනට හදන්න. Quickly calculate. An open system is expanding due to surrounding doing 800 joule work on the system. හරියට කියවන්න ඕනේ හරි පැත්තට තේරුම් ගන්න. Try to understand into correct direction. The work done by the object, sorry, by the system is 950 joules. Calculate the internal energy change in the system. Energy change means final energy minus initial energy always, right? Hari, Hadum, it's a good question. It's an exam type question now. Draw a diagram and clearly understand how it is absorb energy and how it is release energy. Always the work is, I think now you can understand why we discussed previously keywords. The work mean it's a measure of energy transformation, right? What's the answer? Humeth. 20. Others? With me? What's the answer? Humeth? Dulain? Okay, that is it. Humeth, what happened? Sanura, what happened? Okay, the thing you need to understand, very simple. Think this is a system, right? Surrounding doing work on the on the system. Work doing on the system means surrounding doing work on the system mean it is increasing the energy. You mean on the system mean we doing some system, not we, surrounding doing some work on the system. Then what happened? It's absorbing heat, 800 joule absorbing, right? This is the thing you need to understand. Then initial energy 0, then internal energy levels 800, increase up to 800. And in the second chance, the work done by the system is 900. Sorry, the work done by the system is 950 joule. The work done by the system, you can system work right? The system doing work mean it's energy releasing. Energy releasing mean energy waste. You can energy use karna, utilize. Use energy 950 joules. 950 joules. Right? Now what happened? Now think initially 500 joule is there. Now absorb work doing on the system, it is increased up to 800 plus 500, 1300 joules. This is an example, right? If I think 500 joule initial 500 joule, 800 joule work on the system, it is 1300, then 950 joule work doing by the system, right? By the system mean it's 950 joule lost. Then what is the remain? 350, right? 350. Okay. Now delta E, what's the equation? Delta E equal final energy minus initial energy. Final energy 350, initial energy 500. Then minus 150 joule is the answer. මේ මෙතනට ඕන එකක් ගන්න. Any value you can use as initial energy, because in delta E calculation, energy change calculation, we use difference, right? Final minus initial. You met? What happened? Mariam? Dulen? These two words you need to understand. Surrounding doing work on the system mean increase the energy of the system. Work doing by the system mean energy lost. Okay, I got. Any doubt? $150 mean නෑනේ දුලේ. 800 absorb, 950 lost. Then 800 initially, but 950 lost. Then it is minus 150. හරි නේද? හරි. තව එකක් හදමු. Let's do. Always understand these two words. Work on the system mean increase the energy. Work done by the system mean lost energy, right? හදමු. Fourth one. Clearly read the question and what is the answer. And closed system, not enclosed system, a closed system. Internal energy level is 400 joule. The work done by the object is 200 joule. Calculate the energy change in the universe. That was exam question. අපි මේකෙන් පස්සේ let's move into exam questions. What's the answer? Tanur, what's the answer? Okay, what's the answer? You met with me? 20. Tanur, we have a row. Dinul correct. Good. Yeah, no need to calculate. It is 0. Why? Why? This is a system and this is a universe. The system contains 400 joule. The work done by mean work. No. Yeah, system energy change correct 200. You are correct, Madhav. But the question is universe energy change. That's why I told you have to make a highlight karla tibba. Universe. You met? What you got the answer? Met me? Answer 0. Why? The work done by the object system, it is 200. This release heat also may release to environment. The environment also part of universe, right? Then this is a universe. Universe. This is a universe. The universe no any energy change because the according to energy conservation law, the amount of energy in the universe is same. Energy change in the universe it is 0. Understood? You met, Mariam? Let's move into exam questions. Yeah, previous question, if it is asking the energy change of the system, it is 200 correct, plus 200 correct, plus 200 correct, but it's asking system, energy change of the system. All right, let's move into 2016 MCQ question. An inflated balloon with air is expanded due to heat of sunlight. If the heat absorbed into the balloon is 450 joules, the balloon is expanded due to absorb 450 joules. And the work done by the balloons is 127 joule. What is the internal energy difference of the balloons? හොඳට කියවන්න ඕනේ. මේක අහන්නේ internal energy difference of the balloon. Balloon is a system, no problem. Okay, get the answer. Balloon is a system. Now it is asking system internal energy change. මිට ගන්න. What's the answer? Himmet? Yoni? What's the answer? Yeah. It's simple, right? This is a balloon. This is a balloon. Balloon contain 450 joule absorbing. 450 joule absorbing. And the work done by the balloon is 127. Then initially 450. Yeah, initially think it is zero. Initially 0 joule, 450 joule absorbing, and 127 is lost. Joule loss. Now final delta energy equal final energy level 323 minus initially 0. 323, it's plus. Understood? Dinul? හරි. තව තියෙනවා. Let's do this one. It's based on systems. (2016) next question. Which statement is correct regarding thermodynamic systems? You already know now thermodynamic system and process. All known processes are exothermic. All known processes are exothermic? No. Endothermic or exothermic? First one row. All known processes are not exothermic. Boundary of system must be visible to our naked eye. Correct? Boundary of a system must be visible to our naked eye. Correct? No. It is possible to imagine. I told that. All real systems are closed systems. All real systems are closed systems. No. තුනක් තියෙනවනේ. ඕන එකක් වෙන්න පුළුවන්. Total energy of an isolated system can be changed. Total energy of an isolated system can be changed. Total energy of an isolated system. Isolated. Then මතක් කරගන්න what's the meaning of isolated? Isolated means no energy or matter exchange. මුකුත් exchange වෙන්නේ නැහැ. No energy or matter exchange. Then is it possible to change the energy? No. Energy is constant. එහෙනම් පහ වෙන්න ඕනේ. A temperature difference can produce heat flow. Answer. හරි. Let's move into, it is 2018, again asking heat can be defined as. I'm heat කියන්නේ මොකක්ද කියලා අහනවා. Heat is the temperature of system. Completely wrong. Temperature is different thing. Temperature is molecule average kinetic energy. Total amount of energy of system. No, total energy is not the heat. Total energy is not the heat. Flow of energy between two systems, that's okay, but we have to check other answers as well. The amount of work done on the system, it is not the heat. Amount of work done by the system is not the heat. Then the most accurate answer 3. Right? It is not the exact definition, but other all answers wrong. ඒක තමයි පොඩ්ඩක් හරි. I got. Right. Do the 2020 question. The amount of heat provided to a system from the surrounding was 100 joule. The system retained 40 joule and rest was released to the surrounding. The amount of heat provided into a system from the surrounding 100 joule. The system retained only 40 joules and rest was released to the surrounding. That means 60 joule released to the surrounding. The total energy change in the universe. Mariam, what's the answer? Good, Sandra. Yes. You met? What's the answer? Zero, yes. It's asking universe energy change. Universe. Then make it. If it is asking system energy change, මෙතන system උනාන. System. Now what is the answer? The total energy change in the system is. Now what is the answer? The total energy change in the system. The total energy change in the system. Then this is a system. Is universe. System absorb 100 joule and release 40 joules. 40 joule. System energy difference. Now it is 60 joule remain. Initially no any energy, right? Initially 0. Now 60 minus in final minus it is 60, right? 60. 60. You met what I want to. It is not 40. Dinul. 40 or 60. Forty joules released to the surrounding. Sorry. The system retained. Sorry. System retained 40. Sorry. System retained 40. That means 60 release. Sorry. 60 release, 40 retain. Yeah, 40. 40 minus 0, 40. The system energy change. You met what I want to explain? It's released to surrounding. This is a universe. 60 joules released to the environment, surrounding. Which question? This question, make it. Think initially the amount of heat provided to system, the system energy provide from the environment, right? The heat provide to system from the environment. It is 100 joule provide to, 100 joule provide into system from the environment, right? And the system retained 40 joules, and the rest was released to the surrounding. 60 joules released to the surrounding. Then system system also in the universe, the surrounding also in the universe, right? If you got universe, the maiden another system and surrounding, if it is energy change, any type kind of energy change, it is does not affect the universe. The universe always the amount of energy in same, right? System absorb 40 joules retain. 40 joules retain in the system, but it is still in the universe. Therefore, there is no energy change in the universe. Clear? The system also inside the universe, the surrounding also universe. Inside the universe. Therefore, no energy change in the universe. Then make it, may 100 may 40 joules retain and 60 joules release again into surrounding. There is not net change. මෙතන දැන් 100 joule මේ 100 මෙතන 100 නේ තියෙන්නේ. ඒතර 100 joule still in the universe. If it is retained in the system also part of universe. I told you the system is a part of universe, selected area from the universe. Okay, now okay, right? With me? Without universe mean me system එක හිතලා with system මෙතනට system ආවොත් system okay Now think initially no energy in මෙතනට ඕන value එකක් දාගන්න. Initially I got 0 joules in the system. Right? Now surround system absorb 100 joule from the surrounding, then the energy of the system is increased up to 100 joule. Right? Absorb and increase energy up to 100 joule. And it's the system retained 40 joules and 60 joules released to the environment. Rest was released to the surrounding, means 60 released to the surrounding. The total energy change in the system. The total energy change in the system. Now, what is the energy? The total energy means delta E equal final energy minus initial energy, right? Final energy retained is 40 joules. Minus initially it is 0. මෙතෙන්ට ගත්ත value එක දාන්න. It's plus 40 joules. Right? Okay, these remain questions we can discuss after complete the lesson. Today we only discuss very basic things. Api systems itara discuss kare. Next week we are discussing. Next week theory part we can complete and start basic of calculations. Today we did very basic calculation. Okay, go through again and go to these calculations and try to practice. Okay, these chemistry lessons very important because samely physics part, chemistry part also more than loku marks enough, you know, you have 12 MCQ and one structured, 1.5 structured essay and 2 essay questions. It's better if you doing then මොනවා හරි issue එකක් වුණොත් maths question වල හරි physics question වල හරි you have to complete both chemistry questions. Chemistry ටික හරියට කරගත්තොත් within very short time you can complete both chemistry questions in the essay paper, right? It will be huge advantage in time management. මොකද අපි maths questions දෙකම කරත් maths questions very easy, you can get full marks, but the thing is you need more time. දැන් ඔයාලා statistic දැන් ඔයාලා දැන් කරන්න පුළුවන් එකක් කරන් බලන්න area volume අපි දැන් discuss කරපු essay questions you need more than 30 minutes. ඔයාලා maximum speed කරත් minimum 30 minutes you have to spend for this essay question, right? But if you're doing chemistry question within 20 minutes you can complete. ඒ කියන්නේ ඔක්කොම දැනගන්න ඕනේ හැබැයි. Okay, let's start chemical reactions next day and chemical reaction calculations. Okay, do you have any doubt today part? I'll post your tudes both you can get the tude last Saturday. Why you absent yesterday? Okay. ඒ ටික complete කරන්න. ඒකේ අපි yesterday we did the force basic. force එක ඊයේ පටන් ගත්තා. ඒක basic ටික කරා. ඒකේ tute එකත් අරගන්න next day තමයි ගන්න වෙන්නේ. හරි. Okay, then let's meet next week Saturday. Okay, goodbye.